Hey guys, come back with another organic chemistry episode with me, Nkandu. Today we look at hydrocarbons. So to start with, we need to define what hydrocarbons are. So hydrocarbons basically are organic compounds containing carbon and hydrogen atoms only. So we're saying organic compounds containing carbon and hydrogen atoms only. So in a compound, you should be able to see only these two atoms or elements. When a compound is having something more than what I've mentioned here, then does not qualify to fall under hydrocarbons. For example, a compound might contain oxygen, a compound might contain nitrogen, and any other element. For as long as it contains these, that it does not qualify to be called an hydrocarbon. Therefore, I'm giving you a list below. I want you to choose which one qualifies to be an hydrocarbon. So from the list that I'm presenting here, I want you to choose which one qualifies to be an hydrocarbon from this. Okay, the other thing that we have to know is that hydrocarbons, they are grouped into two categories. There are those that we call saturated hydrocarbons and unsaturated hydrocarbons. So this depends on the some of the features that you see that are playing around carbon atom. So we're saying we have saturated hydrocarbons and unsaturated hydrocarbons. So we discuss first saturated hydrocarbons. What are they? With saturated hydrocarbons, we're simply saying we have hydrocarbons which has single bonds between carbon to carbon atom. So when I have this carbon atom, throughout the molecule I should see a single bond linking the two carbon atoms or more. So throughout the molecule, if you have such an arrangement, we call the hydrocarbon to be an hydrocarbon. Now, where is the name coming from? The name is coming from the if you recall from the introductory video that I made, one of the facts that I gave about carbon atoms that it is found in group 4 of the periodic table, and it has 4 valence electrons as well. So in other words, carbon has 4 valence electrons, 4, like that. So when 4 of these valence electrons, when all of them have been used up, we call this particular carbon atom to be saturated carbon. Now when we have this kind of carbon throughout the molecule, the molecule becomes a saturated molecule. This simply means that this carbon cannot absorb, cannot allow any more bonding to take place, and for that it is said to be saturated. And when it is in the molecule becomes a saturated molecule because of the nature of the carbon atom that we have. So we simply say saturated hydrocarbons are hydrocarbons that contains single bonds throughout between carbon to carbon atoms. I'll give an example for this. The example that I can easily give for saturated hydrocarbons is that all of the what's happening with my eraser? Sorry, I'll check back on it. So all of the alkanes that exist, of course, they are saturated hydrocarbons. So all alkanes are saturated hydrocarbons. This is because when all of them, they contain single bonds between carbon to carbon atoms. I want you to observe the structure that I have given below. This is the alkane that exists with one carbon, which is methane. Now this one, basically we're saying this carbon is saturated. But when we look at the second member, which has two carbon atoms, which is ethane this time, we are seeing a single bond again. This carbon has 1, 2, 3, 4, 1, 2, 3, 4. All of them four single covalent bonds. Each one of them, they are saturated. When you check the third member, which is propene, also the same. You are seeing single bonds throughout. When you check the fourth member, which is butane, also we have single bonds throughout. This is how saturated hydrocarbons appear. Now on the other end, we have unsaturated hydrocarbons. Now, what differentiates saturated hydrocarbons from unsaturated hydrocarbons? It's a single fact that the same carbon that we said it has 4 valence electrons. If it has 4 valence electrons, now it simply means it needs 4 electrons or 4 bonds to be stable, covalent bonds. Now, in a situation where this carbon only acquires 3 bonds, like that, it only bonds on 3 sides, 3 bonds, and they remain 1 electron that is not shared. This electron can be shared between carbon to carbon to make sure that this carbon becomes also stable. So it will form a temperate double bond here. So when it forms a double bond here, this is the 1 electron that will be used up to form that double bond. Now this simply means there is still more room for this carbon to undergo bonding, meaning this carbon is not saturated. This carbon can still accommodate another bond. When it can still accommodate another bond, we call it to be unsaturated. So when we have such a molecule, such a carbon being found in a chain, where a chain, we don't care how long it is, but for as long as we have a carbon which is unsaturated, where we're seeing a double bond there, simply means this carbon is not saturated. So once we have such an arrangement, then we simply say the whole molecule attains a name of unsaturated. Because of one unsaturated carbon, it makes the whole molecule to be unsaturated. So if it's an hydrocarbon, it becomes now unsaturated hydrocarbon because of one carbon which is not saturated. So we're simply saying such unsaturated hydrocarbons are hydrocarbons that contains at least a double bond or a triple bond between carbon to carbon atoms. Now in this case I said they might contain multiple bonds. Multiple bonds in this case I meant they might contain at least a double bond or a triple bond. Now why am I saying a double bond or a triple bond? For alkenes they have double bonds. For alkynes they have triple bonds. But going ahead of my lessons, I will not focus on this because it's not part of our syllabus of my interest. But at least we should say the examples that if you want to give examples of all unsaturated hydrocarbons, the examples you give are easy. Just think of alkanes and think of alkynes. Those are unsaturated hydrocarbons. For example, if you look at this double bond here signifies the unsaturation. So when you say double bond here, it simply tells you to say I can open up this bond. When I open up this bond, it's possible that I'll bring it there. So if there's something to add, it simply means this can still react. When I open this bond, it can still react like that. So it is not saturated, it can still entertain more bonding. The same applies to this. This is the easiest alkene that exists. We call it ethene with the 2 carbon atom. And also when you check, we have a double bond here again with 3 carbon atoms, and this one is called the propene, same arrangement. And the third one I'll give is butene with again the double bond there. So the double bond, you can see this double bond there, single, double bond, single, double bond. All this was still saying they are unsaturated hydrocarbons. Hopefully that one is clear. Now I want us to get some understanding about the formulas that we use in organic chemistry and organic chemistry. So the formulas that we use in organic chemistry, number one, we have to understand the empirical formula. Number two, we have to understand the molecular formula. Number three, we have to understand the structural formula or the spread formula. And the last one, we have to understand the condensed formulas. So I'm pretty sure by this stage we are familiar ourselves with the empirical formula. Whether at this stage of your studies, you should be able to explain empirical formula. By talking of empirical formula, we're simply saying these formulas, they show the simplest formula. They're the simplest formula of your compound, meaning they show the number of atoms in the simplest ratios. So in the simplest ratios, for example, if you look at this and that, this is the simplest ratio of the compounds that this is the simplest formula that I can give for a particular compound. I don't know the name, but at least you are simply saying it is showing the number of each atom present in a compound in its lowest ratios. So this is the lowest ratio, but if I multiply each one of these by 2, this will become 4. If I multiplied it by 2, like that, all of them, this will become to be 6, and there will be 2 there, and there will be 4 there, and there will be 2 there. Meaning, the way I wrote it first is the one I'm simply saying is showing the simplest ratios. So if it's showing the simplest ratios, then sorry, I was saying if I multiply it with 2, this will become 6, this will become 2, that will become 4, this will become 2. And this type of formula, again, I know you understand it. It simply means, for us, it simply means molecular formula. So like that. So when I multiply that, it will give me this, it will give me that from that. So that arrangement is the simplest ratio of this. This is the simplest ratio of that. So this is a molecular formula, that's a empirical formula. Now I'm interested in what we have ahead. At this stage, always remember, you just have to know how to write these formulas from the fingertips. Then the other formula that I want us to understand is structure or displaced formula. Structure or displaced formula expresses the number, kind, and arrangement of atoms in a molecule, a compound. So in this case, we're simply saying in here we are going to see the numbers, we are going to see the type of atoms, we are going to see also how the arrangement of these atoms in a molecule. So how are these atoms arranged? For example, if you observe here, this is the first was a displayed or structural formula, because it is clearly telling us how the atoms are bonded and how many are they. So this gives us an example of a displayed or structural formula, because it is showing us that. Also this, when you look at this, it is clearly telling us to say there are double bonds. Okay, So there are double bonds, there are double bonds there, single bonds. So it is telling us the position on which we have the double bond. It is telling us also, it is also clearly telling us to say we have the single bonds between carbon and hydrogen. Between carbon to carbon, at least somewhere we have a double bond, and that's what you're saying as a displayed structure or displayed formula or structural formula. Now there will happen a situation where I won't show you this. I'll write something like this. Hopefully I'll write it well. CH2 CH2. What type of formula is this? This is refers to as a condensed formula. So from the condensed formula, when you see this one, this condensed formula simply clearly tells us to say this carbon is bonded to 2 hydrogen atoms, and this carbon also is bonded to 2 hydrogen atoms, which is totally different when I write it here like this. When I write it C2H4, someone might not know how many hydrogen are bonded to which carbon atom, but when I write it like this, someone will know to say this carbon atom is bonded to 2 hydrogen atoms, and that carbon atom also is bonded to 2 hydrogen atoms. This type of formula is a condensed formula. This is a molecular formula. This and that are displayed formulas. Hopefully I've learned something today. Thank you all for watching. Always remember to subscribe and stay safe. See you again next time till we meet, with me, Nkandu, saying goodbye.